Alright, in this lesson, I'm going to be going over 13.1, Explain 1, and I'm on page 636. And so I'm going to show you how the book is saying to do this, and then I'm going to show you the way that I would do this. And so it says graphing combined transformations for, or of f of x equals b of x. So before we were just doing exponential functions that look like this, and now we're talking about exponential functions that have some transformational shifts. So where base b is still, where b is still the base and can be graphed by recognizing the differences between the given function and its parent function. So I want to first identify what each of these are. So k represents the vertical translation, meaning if it moves up and down. H is the horizontal, meaning if it moves right or left. And A represents the vertical stretch or compression of the exponential function. And so when we would talk about y equals 2 to the x, we talked about those 2 points, 0, 1, and 1, 2, and we could sketch that. Or more generalized would be, if this is y equals b to the x, it would be the points 0, 1, and 1b. And so how do we shift these points? So if we look for the point 0, 1, and 1b, let's see what they're saying. In a transformation, you take the point 0, 1, and it becomes this. And then for 1b, it becomes this. Okay, and your asymptote, which is, you know how when we drew this, it got really, really, really close to 0, but it never really crossed this, that's your asymptote of y equals 0. But now that we're shifting these, we're going to have a little bit different. So our asymptote is going to be y equals k. So the book is saying to memorize these. So know that the point 0, 1 goes to h, comma, a plus k, and that the point 1b goes to 1 plus h, ab plus k. And your asymptote is y equals 0 goes to whatever y equals k is. So these are three things you are more than welcome to memorize. I'm going to turn the page to 637, and we're going to look at these. And so these were the two parent functions that we looked at, or the two exponential growth functions that we looked at in the Explorer. And what happens to them? So here's some shifts happening to 2 to the x. We have a, which is -3. We have h, which is 2. Remember, you have to flip the sign. Since our formula, or the equation that we just looked at on the last one, was y equals a b to the x minus h plus k, you are going to switch the sign of that number that's with x. So it's a -2, so we're talking about h equals 2. And then in this example, k equals 1. So we can apply those shifts that we're supposed to memorize. 0, 1 becomes h, comma, a plus k. So h is 2, so that becomes 2. And a is -3, and k is 1. So -3 plus 1 is 2, -2. So that's going to be a new point on our graph, which is right here. And then 1b becomes 1 plus h, so 1 plus h, so that's 1 plus 2, which is 3. And then b becomes a times b, so a was -3, so -3 times 2, plus 1, because 1 was k. So they're just plugging in numbers here, and they're just simplifying, and they're saying that this is your new point, so we have 3, -5. And then for our asymptote, remember our asymptote goes from y equals 0 to y equals k, and since k was 1, we now have our asymptote at 1. And then we just go ahead and connect these. So we know it has to approach our asymptote but doesn't cross, and then it has to cross these 2 points. So there's what my graph looks like. Now that is how the book says to do it, and again, nothing wrong with that way, but I'm not good at memorizing all of these things. So I just want to point out that, you know, when in doubt, you can still t-chart this out, right? So I'm going to plug in the points 0 and 1, and if I plug in 0, I know how to manipulate this without making very many errors. I also know that 2, if you look, x minus 2, 2 might be a good number to plug in because 2 minus 2 is 0, right? So I'm going to plug in 2, and I'm going to get 0 minus 2 is 0. Anything to the 0th power is 1. So 1 times negative 3 is negative 3 plus 1. Negative 3 plus 1 is negative 2. So I'm going to have a point at 2, negative 2. And then for 1, if I plug in 1, I get 1 minus 2 is negative 1. So I'm going to get, what is that, negative 3 over 2 plus 1. So I'm going to get 1 minus 3 halves. So what is that, negative 1 half? So I have the point 1, negative 1 half, which I can draw right there. And then my asymptote is y equals 1, because it's always what k is. And I would draw my asymptote, and I would still end up with the same graph. So I would usually choose the points 0 and 1, but in this case I saw that 2 was an easy point, so I'm not going to plug in 0. Could I? Yes. But I want to plug in easy points, because a t-chart you can choose whatever values you're going to use. So that was example A. Example B. Let's look at this one. There we go. So I'm going to identify the parameters. So what's A in this? A is 1.5. H is 3, and K is negative 5. And so if I'm doing it the way the book does, I have to memorize that 0, 1 goes to this, and 1b goes to this. And I plug in all of those values, and I find my point. Okay, nothing wrong with doing it that way. Like I said, the book does it, and it works out great. Let's see. This point is 3, 1.5 minus 5 is going to be 3.5. Oh, forgot a negative, right? 1 minus that is going to be a negative. And then this point here, if I plug everything in, so if I simplify 1 plus 3, I get 4, and 1.5 times 10 is 15, minus 5 is 10. And then y becomes your k, so I get y equals negative 5. So I'm going to go ahead and graph these. 3, negative 3.5, and 4, 10. My asymptote is at negative 5, so let me go ahead and draw that here. Y equals negative 5. And I'm going to draw my curve. Let's see. I approach it, but I don't pass it, and then I go all the way up. So using the book's way, you're going to have to memorize these if you're going to do it this way. Memorize those. If you're just going to use a t-chart, remember, choose values that are easy to plug in. Like I would plug in 3, and then I might plug in 4, right? Because 4 minus 1 is, 4 minus 3 is 1. So 10 to the first power is 10, times 1.5 is 15, minus 5. So let's do this. 3 is 0, because 3 minus 3 is 0. And so I get 1 here. 1 times 1.5 minus 5 is negative 3.5. And then if I plug in 4, 4 minus 3 is 1, so I get 10 to the first power. So 15 minus 5, and I get 10. And I would plot those 2 points. So one way of doing it is your t-chart, and one way of doing it is memorizing what the book says the horizontal, vertical, and compressions are. Okay, go ahead and try the your turn 4. Good luck.